Guys, Ms. J here. I'm going to make a video for you of how to go through this matter rotation lab, and just make sure you understand how many stations your teacher actually wants you to do in order to make up this lab. There are 8 stations available. If you have any questions, make sure and ask your classroom teacher. I'm going to go through it like I did with my kids. We are at station 1, and you're going to read the instructions, and you're going to see using 4 different colors we need to color code. I'm only going to demonstrate one because you'll understand how to do the other 3. But I color-coded physical property blue. And so I'm going to go through and I'm going to start color-coding, like it says, these different properties. So my physical properties, all right, I think calling it white is a physical property. I think calling it colorless is a physical property. I think density is a physical property, and you get the idea. And you would do that for all of these. Then once you were done, you would go back to your blue and count how many you think you found. That's the quantity. And so I'm going to make up a number. Let's say 15. Okay, guys, there probably is not 15. Do not write that number. All right, so I'm going to say 15. But then when you come together, you check with your teacher the numbers, you're going to see how many you got right on that. Okay, using the chart, draw the GHS symbol for magnesium and label the chemical property represented. Okay, so for chemical property, let's say I had color-coded that orange. Well, I'm going to come down here. I think flammable's chemical property. I think that is. And it's asking me to draw this GHS symbol for magnesium. So you would draw that here. According to the SDS sheet, the safety data sheet, what should we do if we swallow hydrochloric acid? Okay, so you're going to find the hydrochloric acid SDS. You are going to go to the section heading that you think will tell you what to do if you swallow it. Probably first aid. There we go, first aid. And you would look for what to do if you swallow it. Okay, that's pretty much that for that. So then we're gonna go to station 2. And you will see that your station card, and it is an exact duplicate of the one at the table. Awesome. All right, you're gonna check to make sure you have everything. I know we do because we just did the lab. So here's our stuff. Measure 100 mils of water in the beaker. So you will measure 100 milliliters of water in this beaker. And then it says to use the pipette to add or subtract water if needed. Okay, so let me do that. Let's get some water in here. All right. And we want it to be as precise as we can. So we come down here and whoa, okay, I went way over. Let's fix that. Because you do not want to spend all day using the pipette. All right. So we are going to remove some water. There we go. Beautiful. So we got the water. Sorry, my video is so jiggly. All right, then it says measure precisely 4.2 milliliters of HC2H3O2 in one of these graduated cylinders. Which do I think I should use? The 10 mil or the 25 mil? And chemistry students, you're looking at the increments. I need to get 4.2. Each one of these in the 25 mil is worth 0.5 milliliters. So getting a 0.2 is going to be very difficult. Each one of these is worth 0.2. So there you go. I can get exactly 4.2. Okay, I said exactly, I'm sorry, precisely. Okay, we'll slow it down. And we want our meniscus on the 0.2. Beautiful. All right, good, we did that. Now it's time to dilute or water down the acid, but wait, if we do it incorrectly, it is dangerous. What do you think we should do? Should we add acid to water or water to acid, and why? Okay, and you are going to write down what you think here. Now, since you're not able to do the lab, you don't really need to check with the teacher, but I don't want to tell you what the answer is, okay? So I want you to write down what you think and then see what your teacher says. But I'm going to help you think about this. Look at the equipment. Our acid is in the graduated cylinder, okay? Our water is in the beaker. We have 100 mils of water and 4.2 mils of acid. So what we're considering is, do I add this to this, water to acid, or acid to water? Well, practically speaking, what would you answer? Which one am I even able to pour into the other one? And that gives you pretty much a, it pretty much gives you the answer. But you go ahead and answer the way you think and check with your teacher. If you were doing the lab, you would add and stir. Nice, let's go to station 3. Here we go. Measure approximately 150 milliliters of water in a beaker. Let's do that. Set up our filtration system. Okay, because it shows you how to do it. Nice, let's get our 150 mils of water. Gently. Okay. Actually, that's pretty spot on. All right. And it said approximately, so we're good. Using the spoons, get an estimated measurement. Put 1 teaspoon of sugar and 1 teaspoon of salt into the water. Sugar and salt. Okay, it's an interesting mixture. Stir with the stir rod until they dissolve. So for future labs, if the instructions tell you to dissolve, you really need to be patient and do that. I had students who jumped the gun and got completely false results. All right, so we are dissolved. Now, before I pour it, I'm checking my diagram, and I am missing filter paper. Here we go. Good. All right, here's a neat little trick that you want to learn for when you filter, I'm sorry. Fold it hot dog. Sorry, I'm doing this all one-handed by myself. Fold it hamburger. Pull open one side. Okay, it'll fit nicely into your filtration system. Beautiful. Okay, and then it tells us to use the filtration system to see if I can separate the salt and sugar from this mixture. Okay, I'm already thinking about that. You be thinking about that. Do you think this is gonna work? Pour it in. And you are going to wait. This is the part of lab that is usually not fun and where we start talking to our partners, and we really shouldn't. We should be observing. So be patient. Nice. Look at that. I do not see any salt and sugar. The question is, did you think the filtration would separate the salt and sugar from the water, and why? So you will answer that. Let's go to station 4. Get a nice close up of my papers there. Station 4. It looks very similar to Station 3. And there's a reason. All right, we're going to do the same thing. Let's measure approximately 150 milliliters of water. Nice. I guess you guys can tell that I really like this stuff. Been doing it all day, and it is still fun. So yeah, I'm using the wash bottle to get the rest of my water. Says approximate, I'm good. Cool. All right, using the spoon, get an estimated 1 teaspoon of sand into the water and stir for 1 minute. And as an educated student, I'm just like you. I'm thinking, okay, yeah, I really don't need to stir this for a minute. And if you decide that with your team partners, I know in my classroom, they called me over, they said, Ms. J, do we really have to stir this for a minute? It is not going to dissolve. And I said, good job. No, you don't. Okay, so I'm going to stop. We know that the sand is not going to dissolve because, well, we've all seen muddy puddles. We know sand does not dissolve in the water. All right, there you go. Beautiful. Then it says for 30 seconds, remove as much sand as you can with the forceps onto a paper towel. Ooh, look at that, man. Dang, some of my students did a good job. I only noticed that just now. Okay, way to go, guys. All right, so for 30 seconds, you're like, okay, one at a time. And I had students say, Ms. J, do we really have to do this for 30 seconds? This is horrible. I said, no, good job. It says, would you recommend forceps to separate this mixture and why? You decide. Okay, I know what I think. Use the filtration system to see if you can separate the sand from the water. And guys, you are already trying to think about this because you're going, all right, pretty sure that filter paper is going to stop that sand. So you're making a prediction, which is exactly what you should do in science because you should be curious about everything you're doing. Well, at least in science. What we don't want to do when we get a lab is to not think about what might happen. Always think, what do I think is going to happen? And like me, we're probably thinking the same things, but I won't say it out loud. Okay, we're pouring this in. Did not get all the sand, but I got some. So that's enough. Like, I am going to see the results of this and get the answer I need. So I'm not worried about this. Just wipe that out into the trash can. Okay, we're waiting. And really, I'm seeing the water go through. The sand is not. So I have a solid that did not dissolve, and the filter paper is catching it. Okay, good. Did I think the filtration would separate the sand from the water, and why? And you will answer that. All right, moving on. Station 5. Oh, guys, this is like one of the best. Okay, this is so much fun. All right, so we need 40 mils of hot water. I already poured out my hot water, so I'm just gonna put this in the microwave. That works. Because, sorry, I'm getting my 40 mils. Okay, it says approximate, so don't stress. We know microwaves make things hot, so here we go. One minute should do it. I need cold water. I think I left some. Yeah, there we go. That's cold. It said to get 40 mils of cold water. Yeah, sorry, this is hard to do one-handed. There we go. Get your 40 mils of cold water. Beautiful. Add 2 drops of blue to the cold. And stir with the end of the pipette. Done. Okay. We need our hot water. Ooh, yeah. Okay. Oh, I can't set it on the counter. Oh, that hurts. Okay. Sorry, be patient with me. 1 minute was too long. This is our glassware room. It's very interesting. So you kind of have to put up with me right now because I'm by myself. But, you know, slightly entertaining, so. Could be worse, I promise. Here we go. All right. It says to put 2 drops of red, and look at the diffusion, because you know we heated those particles, so they are moving fast. They stirred themselves. Nice. Now guys, I did something I should not have done. Okay, I touched the hot beaker, and we tell y'all not to, and that's because we don't want you to get hurt. Okay, and I was willing to take the risk, but please do not do that. Okay, really, if I had my students in here, they'd be all over me on that. Miss Drury, sorry, not in a hurry. But that's what happens when you get in a hurry. You burn your fingers, and yes, they hurt right now. So I will suffer because of my lack of safety. All right, pour 3, approximately 3. Good enough for me. There you go, approximately 3 mils of the cold blue water. And now we're going to put approximately 3 mils of this hot water on top. And this is really cool, watch. Oh, it's not doing it anymore. It was, see how it's wanting to come out of the pipette? You're gonna learn about this in gas laws. So there's some gas in that pipette. And you're gonna learn that when temperature goes up, that so does pressure. And so the pressure of that gas is going up, and it's actually wanting to push it out of this pipette. So let me get it over here. There we go. Okay, sorry, buddy. I heated you up too much. But it's gonna make this super, super easy. Since it's so hot, like I don't even have to go very slow. It's just gonna do its thing. Look at that. So both of these were just water, right? The only difference is one is hot, one is cold. The food coloring, guys, is not gonna change the density like that much. It's negligible. There you go. So our hot water is sitting on top of the cold. And you would, you know, draw that. You'd be like, yeah, there's cold. And there's your hot, and it says to clearly label. Voila. Moving right along to station 6. Why don't you go to station 6? There we go. Station 6. So it looks like we're going to do something similar, and yes, we are. So we need to get approximately 40 milliliters of water into each of our beakers. You can see they're labeled, so this is going to be just yellow water. Let's get 40. Let's get 40. Let's get 40. Okay. Then it says to add the food coloring. So 2 drops in the labeled. So this is blue. It says don't stir yet, and that's so you can see the, you know, wonderful diffusion that pretty much you're not gonna have to stir it at all. Not to get the coloring even in there, excuse me, mixed evenly. The water particles will do that themselves. Gas particles move way faster than liquid particles, but liquid particles are moving. You know, matter is always moving. It just depends on how much energy they have, how fast they're moving. Okay, so, okay, so then it tells us to measure our substances. So we go over here. You want to make sure your balance says this first, 0.0. Please do not ever press on the balance. It could break them. We want to get our cup on there because with technology, even though it says 2.1, with technology, I can zero it out. Boom, and now you don't have to subtract the mass of the cup. All right, let's get 5.5 it says. Oh, okay, I need to slow it down a little bit. Okay, so I'm at 5.4. That really could be okay because that last digit, guys, is uncertain. But I'm gonna try. Oh, come on, come on. Nice, because you know, precision always feels better. All right, it says to put the salt into the blue. And then my partner would start stirring that. I'm obviously not going to. But you know, the cool thing is water, like, it's amazing. You'll learn more about that in Chem B. It's going to start dissolving that without stirring. And it will do that faster with salt than with sugar, but we'll talk about that later. This is not what's neat to know, kids. It's what you need to know. So let's get 5.5 grams of sugar. Yes. Does that feel good? Yes, it does. Okay, so let's get sugar in here. And then it says take your stir rods. So stir, and it's honestly, yeah, it's not going to take long. And there you go. The power of water, my friends. Take a little longer, but not much. Yeah, don't be shy and loud, man. Be safe, but get in there, stir it. Now, normally I'd be holding the speaker, of course, but holding it, you could stir even more. Okay. Nice. And then the instructions say, okay, make sure you read, Michelle. Okay, there we go. Yeah, blue. We're going to put approximately 3 milliliters of salt water on the bottom. Beautiful. We're not reacting this with anything, and so it is okay to put the stuff back in there. If we were doing chemical reactions, I would not have put that back in there because I would not want to contaminate my solution. But, you know, what you see happening here is all physical, people, all physical. So just put that right back in there. Now here we do have to go slow. I did have some kids go too fast. It was fun, but they literally just mixed them both and had purple, so. Patience is the key. There you go. And again, there you go. And now, pure water. Hopefully you're predicting. You're like, well, you didn't put anything in there to, like you didn't add anything to it, so it should be the lightest, if you will. And your teacher will talk to you about the terms. Okay, back in. And seriously, come on. Come on. Tell me that is not one of the coolest things you've seen today. Beautiful. All right, and then you're going to draw and clearly label. I'm looking for my blue. Just across the table to be like, yeah. There's my salt. Whoops, sorry. Okay, let's try that again. Salt. Sugar. Oh, okay. Pure. All right. Anyway, you would put that on actually your lab document. All right, station 7 over here. This is pretty cool, guys. So it has you go through these questions, and you're going to need to answer it as you see what happens. So put the colored bar of soap in the bowl of water. And there you go, it disappeared. Do you think this bar of soap is more than 1.0 grams per cubic centimeter or less? And why? And what my students did is, which I loved, like several of them, said, I don't know, but number 2 says to place the white in there. So let's compare and then we'll know the answer. Brilliant. Oh my gosh, the white bar floats. And they immediately had their answer. And I think you will too. There you go. One sank, one floated. So you're going to answer that question. All right, then the fun part. Place a small piece of white soap on a paper plate and microwave it for 1 full minute. Okay? 1 piece. Let's microwave it. I'll show you, sorry. Here we go. All right, and we're going to observe. Oh gosh, all you can see is me. And I know you can't see it very well, do not worry. You will see it when it comes out. Okay, and this video is getting long, so I'm going to stop it, but you would watch it for, we'll see. There you go. Whoa. Now, you're not here to experience what I am. So you can see it looks really fluffy like whipped cream. But when I touch it, the texture is still very firm. You can see that. It's not sinking in there. I will tell you that you can still wash your hands with this. I had my students do that. I will tell you that it still smells exactly like it did before it went in the microwave. All of those are hints for you, okay? And it is still a solid. How about that? All right, and then you're gonna draw and clearly label a model of your observations. One more time, what you're gonna draw. Boom. From here to here. And to draw both of those would actually be more thorough. Start with that, end with that. Okay, station 8. So this is taking density one step further. This is a bonus station. I don't even know if your teacher really wants you to do this or care about this, but literally we take this bottle, we fill it with water, and of course it's going to sink, and then it challenges you to get it to float halfway through. So of course you're thinking, well, when it's full, it sinks, so the only other thing I can do is take water out of it. And you're actually starting to look at buoyancy and water displacement and the forces of the water displaced pushing up equaling the gravitational forces. And so you find out that, okay, you empty the air, it floats like a boat, and this is how huge, heavy boats will float on water. It is why you sink in a bathtub, and yet you are able to float in a swimming pool. So guys, thank you for being here for the Rotation Lab, and keep loving yourself, keep loving science. Bye-bye.